Hello everyone, welcome to another stream of I don't know what I'm doing. So I'm going to throw a bunch of things till it all starts making sense. So what I have to build today, this is a project I've been working on for a client and from a long time I'm not able to work on this project. So I thought let's do live stream and progress it. Just a minute. All right. So think of what is a domain controller? A domain controller is a centralized server that manages a lot of workstations. Best example you could find in your own college. I think in colleges, we do things like for specifically computer science students, they go to their labs and they connect to any computer. They sit on any workstation and they log in their account user account exists in a centralized server and they can log in via any workstation. So this is an ecosystem of domain controller. Now most of the domain controllers we see in whatever enterprise is windows based. It is called active directory, and my task is to replace active directory with some linux alternative. And the best linux alternative that I found is Samba. So Samba active directory domain controller is something I have to use to replace windows active directory services. All right, so I have to do that with a quirk. What's the quirk? um we should be able to log in remotely. What do I mean by that? Let's say you want to use your college uh, let's say you want to use your college user account, and to do that, right now you need to go to your college first. All right, go to your college, go to any lab, and then log in your account to any workstation. But what if I say you can log into your college account from your home PC itself? Your home PC will have the user account and you can work whatever. That is possible via a browser. Okay. My idea is to provide a portal. There will be, let's say, a college portal. Okay. In that college portal, you will log in, and after login, you can see all the um, web applications, or let's say that let's say you get different operating systems as well. You can spawn any operating system on the go, maybe any distro, any linux based distro, or let's say windows operating system 10, 11, 7, whatever. So that's the idea, to make a domain controller network in linux that can also handle remote connections. So there are a lot of technologies merged here. For example, of course, you will need to serve the web requests using a web server. And when I say web server, the first word that comes in my mind is Nginx. So that's why I need Nginx. And um, when I say about having spawning an operating system, right? Then the best use case is this, say, Apache Guacamole. This open source application is clientless remote desktop gateway. Okay, there's something we can launch an operating system in browser, and that operating system will exist on our backend. Okay. So right now, what I have built already, let me show you. I've already built an open sense server. Let me start this. This is the open sense server. I think I should make an SSH connection to it. No, maybe no. Only mess up. All right. So this is the open sense server. See, there are a lot of um virtual LANs, VLANs that I need to make here, but VLANs will actually be made in the real production environment. This is a model. Okay, I'm trying to mimic if all of these things are actually possible or not by building a small model of it. I don't have real servers to deploy this on. Okay, that's why on my laptop I need to build this. I need to prove uh, these things work. Just a minute. Wait. Root. Right. Hmm. So I have made certain networks, subnets. The first subnet is of course the internet. Okay. This will enable us to ping any external network, let's say Google, external server. Sorry. Let me show you if pinging Google works. I think 8888 is the Google's DNS, right? Okay, that works. The ping works. And if I enter google.com as well, that also works. So my internet subnet is working. All right. The second subnet is DMZ. What is DMZ? DMZ basically means demilitarized zone. And when I say demilitarized, what do you think by the word? Okay, demilitarized. A place where there is no military means there is no security, kind of. Okay. Basically, this is the public facing server. Okay. Uh, Later on, for remote connections, right? I need to build a static IP, and that IP will have a domain name. Let's For my client, I'll tell you the domain name. Let's say college.com. When you open college.com, your college.com, it will internally ping this DMZ and Nginx. DMZ will contain public facing Nginx servers, and those Nginx will load balance the request to WSO2 servers that exist in internal subnet. Okay, so there comes internal subnet. Internal subnet is totally cut off from internet. You can't access internal network at all. So that's for security. Okay. uh, the best security is achieved when you can't do anything literally. So I will disconnect this internal network from the internet completely. There will be no internet connection. um Nginx need to serve request. Nginx will have internet connection, public facing DMZ. Nginx will then load balance the request to WSO2 servers that exist in internal. WSO2 servers will help in login credentials, and after the login is successful, um, the Nginx will serve a web page, the dashboard to you, and the dashboard is also presented by WSO2. Finally, in this setup, this Apache Guacamole comes into picture, and between our main backend where the hypervisor exists. In that hypervisor, we have a pool of virtual machines, right? So uh, this WSO2 will send the request to Guacamole. Guacamole will spawn a virtual machine in the pool of virtual machines, and that virtual machine will be served to you live via Nginx. So that's the idea I have in my mind. Okay. But uh, okay, there need observability subnet. What is the observability subnet? Okay, I as an admin need to monitor a lot of things. For example, who logged in? Okay, who logged into my matlab, I am, let's say, college IT department head. Okay, and I need to know all the statistics kind of things. Okay, who is logging in, who is doing what files are accessed, what files have what permission. uh, I need to be able to lock someone's account, to reset someone's password, okay, as an admin. So those things, those admin things, uh, which are hidden from public, of course, that those things will exist in observability subnet. The admin can observe everything that is happening on the servers. Okay, so this is the whole system, DMZ, containing two Nginx servers. Those two Nginx servers basically are load balanced. Sorry, I should tell you about this diagram. Um, where's the diagram? Just a minute. There's our DMG. All right. The DMZ contains two Nginx servers, Nginx 1, Nginx 2. These two servers are redundant. Let's say somehow our server 1 fails. It goes down. Okay, downtime. So this goes down. This will handle all the request. Okay. Now these servers will communicate with what? Internal network. In this internal network, what we have WSO2 server 1 and WSO2 server 2. Again, this is redundant. Let's say this server goes down, you will be your service will still be alive via this redundant server, and the requests between these are load balanced. Sometimes this round robin algorithm, and between WSO2 and our main hypervisor that contains the VM pools. This is our Hyper-V. Okay, and our Hyper-V contains a big pool of a lot of wait a lot of virtual machines. Between this Hyper-V and WSO2, there exists Guacamole, let's say server 1, server 2 again. And I'm not making server 2 in this diagram for now. And here you see, yeah. Actually, I should color code this different because getting hard to see. Then there is our observability subnet. This subnet contains all the databases DB1, its redundant partner DB2, because data is very crucial. We don't want to lose any data. And backup servers again, and all the monitoring tools, monitoring and what do you say, logging. All right. Um, to manage templates, because this VM pool needs to have um wait, I really forgot to make the main thing here. You know, the title of this video, domain controllers. Domain controllers need to exist above, WSO2, because that's the main thing. No, actually, WSO2 needs to exist here. Oh, sorry, WSO2 only. Domain controllers. So here is domain controller 1, and its redundant partner is called additional domain controller. So ADC1. Domain controller for 1 and ADC for 1. Okay. These two are redundant partners. Requests are served into these, right? And then they get a chance to serve to via guacamole. Ah, so this is kind of another thing to because this domain controller is based on Linux, all right. But I also need to manage Windows-based operating systems to actually make the policies, make the permissions. Like, let's say there's an account for a student. There is a limited set of permissions for student. A student cannot open a control panel. A student cannot install a malicious software. So I have to limit those permissions. This is called policies. I limit the policies of a student. I extend the policies of an admin. I extend the policies of a teacher, let's say. So basically, the authorization of each account is managed by uh, is managed by what happened? The authorization of each account is managed by some servers as well. For example, I actually need a Windows VM server. Windows, let's say Windows 10 or Windows 11, server VM, server virtual machine. And this virtual machine will help me to make the policies for any Windows based account. Okay. It's really hard to make Linux accounts, to make matlab, Windows accounts on Linux machines. Okay. So we kind of bypass this problem entirely by using Windows itself for making Windows based accounts. Okay. So I'll tell you when we reach this, but basically this will connect to our ADC and help us to make Windows based accounts. Okay. Between this, there is another thing that makes our internal network even more secure. You get it, right? We need to install some packages, some softwares in these domain controllers, guacamole, etc, right? But how? How means, do you actually understand? We are not going to provide this any internet connection. This will be totally cut off from internet, from world, then how can you install packages? If there is no internet connection, you cannot download anything, right? So you need to make make a mirror server. What is a mirror server? A mirror server is basically a special type of server that contains a lot of packages. Mirror server has internet connection. Okay. A mirror server has internet connection. It has a lot of packages. You can download any package. And now any internal network server will download the packages not from internet but from this server. Okay, this mirror server. So how does it make our environment secure? It actually makes our environment secure by um you see, whenever you download something on your mirror server, you have to test it. And if something breaks, or let's say you find something malicious, then you will not install that particular thing from the, what do you say, from the you will not install that version of that package. All right. So this is just a like 2FA security check. You install things on a mirror server, you test it. If things fail, you just revert back. You don't install. Let your system work without updating. Updating is very nah. Don't migrate unless you need to migrate. So I need to make a mirror server here. Now there's a catch. You need to have a mirror server for Linux as well as this Windows 11 server VM. Okay, which will eventually provide updates to the Windows workstations in the VM pool. But you know, making a Windows server, I don't really know. I have quite experience with Linux, but let's say, uh, let's say we are able to build this. Let's say we are not able to build this. Let's not worry about it. So we have a mirror server. Mirror server. And this basically connects like this. So this is kind of the whole picture. And I have already built what? The OpenSense server. This is the firewall. And the DMZ, the internal network, the observability server, everything is secure via this firewall. You need to ask yourself, how will you cut off the internet? I'll basically make a firewall rule that nothing needs to go beyond this internal server. Okay, I, firewall will just block everything. You can't access internet. And this is connected to internet right here. Okay, so this is the complete picture, kind of system diagram. All right, I have made the OpenSense network, TMZ internal observability, and I need to build this complete picture, this bottom picture now. So let's begin with mirror server. Hmm. Just a minute. Ah, I hope I took a lot of time to explain such a basic thing. Mm. I do have a lot of virtual machines already installed. So I don't need to waste the time of this stream to install such big packages. Actually need Ubuntu Live Server. Okay, let's make the mirror server. I'll name it Mirror One, new virtual machine. Mirror One. I'll store this as a single file, so the disk IO will be faster. Customize the hardware. Please give it somewhat less because you see there are a lot of servers. I need to open a lot of virtual machines all together. So even though I have 32 GBs of RAM, it's quite limited when you need to open so many servers. Okay, I'll limit it to 2 GBs of RAM and processors. Let's say, I guess it's fine. I guess it's fine. Um, it's that's limited, and I need to connect it to my internal network, right? So internal network is on VMnet 3. I have made some VMnets, मतलब virtual machine networks. So network adapter, custom. My VMnet 2 is DMZ, 3 is internal. So I put 3. Do I need anything else? I guess not. Wait. If I need, it's fine. Let's see. If there's any problem, we'll deal it on the go. Finish. The new Ubuntu server VM is gonna create. Let's power on. Sorry. It's just too small. Try or install Ubuntu server. Yeah, I need to install. You see, I think there will be no internet connection for now. I think. Let's see. It will be really difficult to. I'm making a mirror server for the first time. I don't know. See. Continue without updating. If the internet works, I'll update later on. English US keyboard, fine. Ubuntu server. Now this is the part. I also need to enable nick teaming. What is nick teaming? Nick teaming is basically in real production servers, you have multiple nicks. What is a nick? A network interface card. It basically provides you the internet. Okay. So you put two nicks just in case one nick fails, your server will not be disconnected from internet. Okay. So here on the operating system on the software side, you basically provide one IP to two different interfaces. All right. I have two Ethernet connected to my machine, two Ethernet cables. Okay, I have two Ethernet cables connected to my machine, but instead of giving them two different IPs, I will bond them together and I'll provide a single virtual IP to them. And that single virtual IP will float between them. Okay, if one wire, let's say if someone comes, if a rodent comes and cuts my one Ethernet wire, that virtual IP will still be present on the second Ethernet, right? So if one connection fails, disconnects, nick destroys anything, internet will still work via the second nick, second Ethernet. So that is nick taming, and for that we create bonds. But right now I'm not creating a bond. Okay, we have VMnet 3 here. The interface is ANS33. ANS33 is has been put on this. Okay, I also have VMnet 8, the NAT. Let's just see settings. Do I have VMnet 8? I didn't delete it, right? We have. So this is connected to internet, but I actually do not want it to connect to internet by itself. I'll allow it internet via firewall. Okay, my firewall will distribute the IPs, and this will have the IP of my subnet. So I need to delete this. I think I should shut down before, because back. Let's say I turn that off. So slow. Connected. No. Not connected. Okay. You don't see the IP address here now, which was provided by the DHCP server automatically. This ENS34 is the network I actually need. So actually create bonds. I will need another VMnet, but I can do that later. Let me screenshot this and keep a record. Their server. I'm taking some notes. I have my VMnets created till 2, 3, 4, 4. Create VMnet, another VMnet 5. Use that on all the machines to make the bonding of interfaces nicknaming. Okay. I need to completely rip off the NAT from here. I don't want this ANS33 at all. I mean, this ANS33 will be created at this one. Need to ask GPT. VMnet 3. Still shows two interfaces here, but one of it. Actually, wait. I think I can do without AI. Let me just let me just shut this down. See, I can make this custom. I can make this VMnet 3 and I can delete, I can remove this, right? So you see, ANS33. Okay, now I need to provide this an IP address. This IP address, if I had a DHCP server on my OpenSense, maybe this would have got an IP by itself. But the catch is that I do not have a DHCP configured on my OpenSense. Okay, maybe I should make the DHCP server. See, this is my local network firewall OpenSense. I'll use the same credentials. DHCP services, DHCP. Hmm, This one. Um, The Ubuntu installer is waiting for DHCP lease, but VMnet 3 is host-only network with VMware DHCP disabled, and OpenSense is not running a DHCP server. That's why this interface shows not connected and disabled. Cancel the Ubuntu installation. Yes. Enable DHCP on internal interface. Services DHCP internal. All right. Services DHCP. There is no DHCP with this. Nah, nah, nah. There's nothing. There's nothing right here. This is DHCP v4 internal. You should see your internal interface. Enable the DHCP server. This is you are using a newer OpenSense release, which have switched from the legacy ISC DHCP server to Kia DHCP. That's the one you should configure. Open DHCP, right? Enable services. There should be a checkbox similar to enable Kia DHCP server. Agent enabled. Apply. Um, Meanwhile, I should cancel the installation. Maybe I can just go back. Okay. Find address, port, add a subnet. Inside the Kia DHCP page, there should be a section for subnets or subnet 4. DHCP 4. Maybe I enabled something. Something's wrong. Kia DHCP 4 enabled subnets. Interface internal. Domain name, domain search. Yeah, this is the right subnet, but description internal maybe. Pools. Pool start 50, pool end 60. Hmm. Wait. There's no pool start and pool end. This is confusing me. But once it's configured your internal network. In settings tab under interfaces, selected internal. Create the subnet. Internal network. Enter. Disable auto collect option data. At the gateway to further down, find the routers, sometimes under DHCP option data. Enter DHCP option data, router gateway 33. Yes, my router gateway is 33. My OpenSense is itself acting as a router, I think. So yes, its IP is 33. Find DNS servers and enter. Later we will change this to 41 or 42 for DC1 and ADC. Okay. Why do you need DNS right now? DNS servers. Domain name. Restart किया. Already. Why are you configuring DNS here? Because DHCP is responsible for telling clients which DNS server to use. For example, when your Ubuntu VM boots, it broadcasts DHCP discover, right? The DHCP server replies with something like this. The client automatically configures all of those values. Why I suggested ये temporarily? Because your architecture looks like this. There is no domain controller yet. So there is no internal DNS server. Your Ubuntu machine still needs to resolve names like these. So it needs some DNS server. If you tell your DHCP to give out, then in that case you need two DNS, right? One DNS will be the one which knows these values, and another DNS will be, of course, the domain controller, which will resolve all the names from workstations. DC1 DNS. It's, it would not receive a DNS. The VM could ping, but it could not receive. You are right. In that case, I think we might need two DNS servers. One here in open sense that knows how to resolve external names, and another of the domain controller. Another of the domain controller, which is completely private and only resolves A DNS server can manage both internal and external names. In fact, that's how Active Directory is designed to work. They do not normally run two separate DNS infrastructures. Enterprise OpenSense firewall, DC1, DC2. Clients never query OpenSense for DNS. They ask DC1 or DC2. What happens when a client asks for Google? The flow is, does Google one exist in my zone? No. Forward request to this gets answer, returns answer to client. The client never knows Cloudflare exists. What happens when a client asks for DC1? The DC DNS has two jobs. Do not touch a single client. When client renews DHCP and automatically starts using domain controllers. Since itself needs to resolve names, for example, resolved. Internal server network, infrastructure network. Repo one, internet allow firewalls via firewall. Again, do you mean DC1 can still resolve all the names, but if DC1 asks to resolve a domain of external network, it will simply be blocked via the firewall. Introduce that separate network sooner. You place the mirror on the same internal network as domain controller because you hadn't created an infrastructure network yet. This separation gives you exactly the behavior you were aiming for while keeping the architecture clean and easy to enforce with firewall rules. That does make sense, but when I studied the topic before, it wasn't quite like this. It specifically said me that it specifically told me that I need to deploy this mirror server on the internal network itself, but internal network has no internet. Well, this does make sense. Let's see. 33 domain name. What was my domain name again? Okay. Save and apply. I've restarted the DHCP. Launch my virtual machine again, and this is disabled. IPv4 automatic DHCP. Save. DHCP is not working. Okay, there is some problem. The internal network. Should I completely cancel down ever created? I just hope it gets a DHCP, an IP address from DHCP. You won't be able to connect, bro. There is no internet. It will just fail and continue. Dump. Just fail already, man. Good job. Ah, I got the IP. The DHCP is working. Yay. Okay. So exactly like this, I would need maybe I should just rename this network to infra and make another internal network, another subnet, because this network right here can support 8 subnets because I've used, you see, slash 27, slash 27. Slash 27 basically means that I have borrowed 3 bits from the class C network, and 3 means 2 to power 3. 2 to power 3 is 8, so I can make 8 different subnets, and right now I have 3 subnets. So I can easily make fourth subnet and call it internal, and that internal network will have my internal infrastructure. But let's see, for now I have to make this work. There's no proxy. Let's see if archive.ubuntu.com works or not. Maybe the firewall rule is denied. This won't work unless I allow internet on the internal network from firewall. Okay, this won't work. Do I need to? DHCP is working. You almost certainly need a firewall rule. Incoming traffic on internal deny. Automatically created by Kia. Create a temporary rule. It's internal network. I'm totally ruining my infra design by allowing internet to internal. But maybe I'll just rename this network from internal to infra and make another internal network. And okay, let's see. Why are you saying temporary internet access or mirror? Mirror will have temporary. Right now you have internet network that only contains mirror one. Subnet is acceptable during bootstrap. But I will tighten this. Yes. Internet allow. Why can't I do internet allow here and block for everyone else? No. Action pass on interface internal protocol any. Okay. Source internal network. Source internal network. Destination any. Description internet allow for mirror. Can't I simply allow the internet to this particular IP that is 10.10.10.50 and the rest all will be cut. Hence, I won't need another subnet of infrastructure. Source, a particular source, not all. Single host or network. No, cannot put an IP address here. Um, internal network, single host or network, internal network, OPT2. This is disabled. I would not let the mirror keep this via dynamic lease. Instead, I'll give it a permanent identity, static IP, configure the mirror itself with IP40. Then your firewall rule is permanently source 40, no DHCP dependency. DHCP reservation, leave the virtual machine on DHCP, but create a reservation in OpenSense. Always hand out a particular MAC address to this IP. Okay. The mirror still uses DHCP but always gets the same address. I understand this is the static IP assignment, but do know it's the firewall. I can assign the static IP later. Do this right now. Steps to configure reservations. Man, we have reservations here as well. Don't see any reservations here. Maybe leases. IP address lease. Reservations. You will need the MAC address of mirror 1, mirror VM settings, network adapter. Actually, you know what? Um, help enter shell IP link. What is my MAC address? My MAC address is 000C2998E45. PF. Um, can't copy it from there, so I need to switch back and forth and make this. Okay, this subnet. The IP address that I want to reserve is 10.10.10.40, and the MAC address is 000C 2998 E4DF. E4DF. Host name is mirror1. Description. Uh, the mirror server. DNS server maybe just 10.10.10.3. Main name. Save and apply. Should stop and start again. And I should exit here. I should power this off again. Ah, okay, let's see. Let's see if this gets IP of 40 automatically by my DHCP server. Means, you see, I have leased 50 to 60, but 40 is reserved for this particular MAC address. Let's see if it works. You won't be able to ping. And why are you even trying? Maybe I should create the firewall rule. Does start pinging. Never hard code IPs in firewall rules, instead firewall aliases. Okay. Firewall aliases. I have to create a new alias. mirror server name, mirror server, type host, address, type host. I don't see a column for address, you know. The content is the address field. Okay. Let me see my mirror if it. Yeah, it got the 40. Yes, yes, yes. Now I just need to ensure the firewall works. So now every firewall rule can simply reference mirror server instead of an IP. If the IP changes later, change the alias, not every firewall rule. Wow, this is amazing. This is like object-oriented programming on firewall. Okay. On internal network, I'll make a new firewall rule. Pass, interface internal, sources, mirror server, okay. A destination is any, okay. Internal, okay, okay, mirror server any. Allow mirror internet. Allow internet to mirror. Immediately below it, add action block. Why? I mean, this rule is applied to only in mirror server, right? So I don't even need to configure the rest of the fields. I changes. Maybe it's just a fail-safe mechanism. So does the internet work? Hi, internet is working. Wow. Yes, 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 yes. I'm happy. Okay, it's done. Continue without updating. And oh, where's the SSS part? You know, I think there's an SSS part I'm missing. Am I missing? Use entire disk, of course. Done. Done. Continue. Your name, Devesh. Your server's name is Mirror One. Pick a username. I think the user that I should make is, I'll leave it, admin at 123, admin at 123. Done. Skip for now. Enable open SSH server and import SSH key from my GitHub. So, uh, this will actually enable me. I have already my SSH public keys in this account. I mean, this. machine. Okay, so I will be able to access this virtual machine easily because I already have that key on my machine, right? So fetching SSH keys, yes, this is the right public key. I have private keys on my machine. This is the public key. Done. No, I do not need uh any this right now. Let it just install. So guys, I'm taking a break of the time this is installing. Let me just confirm. Okay. Hello. So it's done. Let's reboot the machine. All right. Mirror one login. This works, but I need to SSH in it. Okay. Yes. Now that the server is set up, I need to install some packages like aptly, etc. to wait. First of all, first of all, I should fresh install. Now just reboot. I mean shut down again. Just updating the packages, the default packages. Open VM desktop. I guess this was the package name. Open VM tools. Yes. I remember the package name. Wow. After this, I'll snapshot again and shut down again. Shut down. Power on again. I should cap its RAM somewhat more. I don't want it to consume a lot of RAM. Why is this guest OS? Wait, disconnected it from the ISO file. So maybe it won't itself to like pen drive. I've capped it to use just 1 GB of RAM. Very limited. Okay. It's just APT mirror is old. Yes, I don't want that APT cache ng caches packages after clients request them. do this. Localhost mirror one. And not start by itself. Install Nginx. Yes, this is running. Server repository. Make directive doesn't exist with root user as alt user. I mean the main user. The survey repository. Install aptly. Yes, I know about aptly. I paste this. Packages enter your repository. There are two fundamental different models. Local repository, it is download only requested packages, import into aptly, publish, offline servers install. Option B is Ubuntu Mirror, Internet Mirror Ubuntu repositories, publish, offline servers install. Of course, I need this. I only need requested packages. I don't have hundreds GBs of storage to actually install the complete Ubuntu repository. Okay. We will build an enterprise local repository where packages are imported on demand. Then we will automate it with the add package.sh script we designed earlier. Okay. This keeps the repository compact, under your control, and perfectly aligned with your offline accept mirror architecture. Done scene. This is exactly the model I would build. Okay. Happen because is owned by root while you are running apply as a normal user. Let's avoid running apply as root. Let- make your own, make your user own the repository. User devesh, group devesh, recursive on everything from this. This will verify. You see, now the user and group both devesh. Now if you do this, no local repositories found, create one with aptly repo create. Aptly repo create enterprise. Aptly repo list enterprise. Create the publish endpoint. Publish repo enterprise. You will probably get a GPG signing prompt. Skip signing for now since you don't have your internal C or repository signing keys. Publish unsigned. Later, after our internal PKI is built, we'll generate GPG key and republish everything with signatures. Okay. How's my stream going, by the way? That's good. Create enterprise. Aptly repo add enterprise to add packages to repository. That's easy. But this way, you know what? I need a way to get all the packages like in a tree. Let's say, let's say we have a given package. Okay. Now we actually need a way to get its all dependencies, make a dependency tree, and all the packages in that tree, add them to enterprise repository. Yeah, I do see enterprise. Unable to publish. Publishing from empty source. Architectures list should be complete. Can't be changed after publishing. Unable to guess distribution name. Please specify explicitly. It doesn't know what Ubuntu release this repository represents. Distribution noble component name. Skip signing true. Architectures AMD64. Publishing from empty source. They set up a web server to serve the directory public with auto indexing. Now you can add following line to apt sources. HTTP your server. Okay. Don't forget to add your GPG key APT with APT key. However, I would actually not publish empty repository. It's harmless, but there's no benefit. Let's first add a package. Make directory incoming, download htop, import it, repo add start, publish it. My repository already contains one package. This is where I want to change the workflow. We are at a point where everyone on the internet starts manually doing download package, repo add, publish update. I don't want you to ever do that manually. Instead, the very next thing we are going to build is internal package manager for our repository. You'll simply type repo add htop and the script will resolve all dependencies, download only the missing dep files, import them into aptly. Yeah. What is this, man? Repo cache. Okay, this is not complete. Oh, actually, that was complete. I'm sorry. How do I undo? Shift U? Okay. I moved it. Clipboard provider. And my plus registry is was working. Wasn't it banned? Yeah. See what it makes. What is this? Okay. How much time does Claude take on average? Now thinking of it. Let her make the best script I've ever seen. Guys, this is taking just too much time. A very my plan will simply go out of credits. And you just need to make one single file. Why do you need to making it in JavaScript? I knew it. I knew it. I knew it. Claude is just shit, man. Right? Let me give it a try. Our beloved Gemini. Update on. I'm currently here. Mirror server. If this is built, I'll look into that bonding part. I'll simply verify if my pings work if I disconnect one VMnet. Okay. After this, I actually need to set up my domain controllers. The domain controllers will give me, they will just simply set up the environment, and afterwards, I need to look into WSO2. And after the WSO2 is complete, then I need to load balance them via Nginx in DMZ. So, meanwhile, this is done. I would not run this in production yet. There are several issues ranging from won't work to architectural problems. Problem one major wrong package identity. The resolver extracts package name from apt-get. Later it compares against aptly repo search. This is unreliable. For example, let's say I install this versus OpenSSL, AMD4 or some other version. Packages should be identified using name, architecture, and version, not just the name. Otherwise, upgrades will fail. For example, here, Linux. The downloader uses URL lib to download packages. No, never. apt already knows. Mirrors, retries, blah blah blah. Don't replace it. Use APT. The repository search called every run for 40 packages, fine for 25,000. This is terrible. Better would be actually package search or package show. Cache never expires. Will eventually contain 40 GB of packages we need. Publish every command. Republishes enterprise systems usually do. Add all and then publish. Publishing is an expensive operation. Repo consistency. Need transaction support. Two admins. No lock. Repository corruption. No signature verification. Missing package database. Everything requires apt-tree. Eventually you will want search, stats, info, graph, should cache my data locally. No unit tests, integration tests, dry run, dry run output. Would download 43 packages without changing anything. No progress bar. Install script. Almost 6 p.m. So, guys, I think I'm going to stop stream for now. The next steps are to actually first of all build this script, manage, publish packages. Second thing is then to make the DC and ADC with rsync. Then let's say we also create a new VMnet 5 for bonding. Finally, no, I mean in WSO2, then Nginx. I mean, you need to verify the working of PC and ADC. So Windows admin VM, Linux workstations, Windows workstations, Step 9 is WSO2, then Nginx. Finally, guacamole. There is important thing I'm forgetting. Prometheus and what was the name for it? Um, Elasticsearch, Grafana. This is 12. So guys, see you in next stream. See ya.